All right, so let's look here at a couple of the textbook pages for this particular TEAC 468B. My learning targets, I can transform parallelograms, trapezoids, and triangles into rectangles by decomposing and rearranging the parts. Well, we kind of did that backwards. We took rectangles, decomposed them, and transformed them into parallelograms, trapezoids, and triangles. But the idea is that you can move from one to the other. I can use decomposed models to develop formulas for finding areas of parallelograms, trapezoids, and triangles. So this next page here, it says, how would you describe the process for determining the area in square units of the rectangle? Well, we know how to do that. We take what they're calling the base, or what we call the base, and we're multiplying that by the height. And so here I have 1, 2, 3, 4, 5 units times 3 units. And so just like my index cards, I have 5 units times 3 units, which is my base, times height. What formula using B and H as variables can be used to show the process for determining the area of the rectangle? Well, that's area equals my base times my height. Number 2, draw a diagonal line from corner to corner to partition, or to break into parts, the rectangle into 2 congruent triangles. Then it says to shade one triangle, and then it says, how might you determine the area of the shaded triangle? Well, as we talked about in our lab, area of the triangle is 1/2 the area of my rectangle, which was base times height. And so what formula can be used? That formula right there. And what is the area of the triangle? Well, that's going to be half of 15. So area equals 1/2 of, so multiplication, 15. And so my area is going to be equal to 7 1/2 units squared, or square units. I'm going to go ahead and show the rectangle here, or the rectangle is a 2 by 4 rectangle. So that's a 2 by 4. And so my area is going to be 1/2 of 2 by 4, or 1/2 of 8. And so I know my area is going to be 4. And we could do this in any order. I could say that, because again, multiplication is commutative. So I could, if I wanted to, say 1/2 of 2, which is 1. 1 times 4 is 4. I could say that it's 1/2 of 4, which is 2, times 2 is 4. Or I could say that it's 2 times 4, which is 8, and then half of 8 is 4. How do you know the process for determining the area was effective and your solution is reasonable? Well, we can see, and we've seen in many examples, that any triangle is half of a parallelogram, in this case, half of a rectangle. How is finding the area of a triangle different than finding the area of a rectangle? Well, it's half. So whatever my area of my rectangle is, the triangle is half. Let's look at this next page here. Circle the base. That's going to be important here. Circle the base in the following figures. Now my base is always perpendicular to my height. So if I know where my height is, I can find the base. So here is my height. So then I'm going to circle my base. Found my height. Here is my base. Now, don't get confused and say, oh, well, this is how tall it is, right? From the bottom to up here, that's my height. Well, no, because my height is always perpendicular to my base, or my base is perpendicular to my height. What shape is this? This is a trapezoid. My bases of my trapezoid are always going to be my parallel sides. So I need to circle my bases, and they're also perpendicular to the height. So I need to circle my bases of my trapezoid. So here I know my height, so I'm going to circle the base. Here I have another trapezoid. My bases are my parallel sides. Same thing here, circle the height of the figures. So here's my height. My height is always perpendicular to my base. Now it says to circle the altitude of the following figures. Here's the trick. Altitude and height mean the exact same thing. Altitude is my height, my height, my height, my height. Last page that we're going to talk about today. So we've already saw this in our lab by determining the area of a parallelogram. So what we do is we can cut it If we cut the parallelogram here and rearrange it, then we can make it into so this is the cut and this is the cut, right? So we can rearrange it into a rectangle. And so we did it the other direction in our lab, but it's the same thing. So my area did not change. The amount of paper in my index card did not change. It's still area equals base times height. Area of a trapezoid. This is the one that I told you in the labs. They're going to show you something different in the book, and that's okay. There's multiple ways of exploring this. But here, I have my base 1 and my base 2. We talked about that already. And I have my height. What you can do with any trapezoid is you can cut it in half this way. And again, you could just fold it over and cut it in half. Then rearrange those two pieces. And now I have my base 1 and base 2 create the base of my parallelogram. And then here's half of the height. Instead of the whole height, now I have just half of the height. So it's 1/2 of my base 1 and base 2 times my heights, right? So 1/2 height times my base 1 plus my base 2. I could multiply in a different order and still get the same thing. So I have 3 terms. First term, second term, and my third term. So here they're going to give us 4 practice questions. We're just going to go through this very quickly, and you guys are able to start working on your own. Use the grid to sketch how Quan can rearrange the parallelogram to form a rectangle. So what Quan can do is Quan could cut off this piece and move it down here. And so cut that piece, move it down there. And so what we now have is a rectangle. All right, number 2, how can you determine the area of the rearranged parallelogram? Well, all we got to do is just find the area of the base and the height. It's really, really easy. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. Going that way, 1, 2, 3, 4, 5, 6. So 6 times 9 is 54. So that's my area, and these are square units. Write the formula to find the area of the parallelogram. Area equals base times height. Find the area in square units. Well, we did that. So area equals, we said it was 6 times 9 high, and that was 6 times 9 is 54 units squared. And my final question, how is calculating the area of a triangle similar to calculating the area of a rectangle? Well, we talked about that. It's half of the rectangle. And how did having a prior understanding of determining the area of a figure help you to be successful? Well, what we learned in 3rd and 4th grade helped us to get an understanding and provide a baseline for what we're talking about with these other polygons and extending that knowledge to these other polygons. So hopefully this was all helpful. Once again, if you're confused by any part of it, pause the video, go back, rewatch it. If you still don't understand after watching the video multiple times, I will see you in the Google Meets help session.